And we're live. Okay, and where are we? Page 9. Alright, here. Order the following set of rational numbers from least to greatest and explain how you determine the order. Okay. So, that was me. Thankfully it's not. Sorry. Let me copy the numbers. You got 0, negative a half, 1, negative 3 and 1/3, which is not written like that. Where am I? Negative 3 and 1/3, 6, 5, negative 1. Sorry, they're all bunched up. It's because my screen is small. And 4. I'll put commas. Comma, 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 comma. Alright, so if that was me, I would create a number line and start placing them. Okay, 0, 1, 2, 3, 4, 5, 6, and I would go negative 1, negative 2, and negative 3. I don't need to go negative 4, negative 5. So let's go 6 both ways. Okay, so as you place them, make sure you cross them out. So 0, that's very easy, it's right here. Negative a half. You know what? Let's take a different approach. Let me do all the positive integers. So 1 is right here. And I have 6, which is right here. I have 5, which is right here. I have 4, which is right here. Look at that. I got rid of a lot of numbers. And then let me get rid of the easy negative numbers. The easy negative number would be this one, negative 1. There, I put in my number line. And negative a half. Okay, negative a half, it's between 0 and negative 1. So that's negative a half. And that's gone. Now I've got negative 3 and 1/3. Negative 3 and 1/3 is negative 3 and a little bit more, which is about here. Okay. And then, what is that? Negative? Oh, no, it's 21 over 5. 21 over 5. Okay, if you want to change it to a mixed number, you get 4 and 1/5. So that's going to be 4 and 1/5, and I'm going to make that going down here. That's too easy, actually. 4 and 1/5. Explain how you determine the, well, to determine their order, I use the number line, and I start placing them. And now I can easily put my numbers in order, and I know that my numbers to the far left are the smallest ones, and the numbers to my right are the biggest ones. So in order, it would be negative 3 and 1/3, negative 1, negative a half, 0, 1, 4, 4 and 1/5, 5 and 6. Easy question. Okay. And that was page 9, and then we're going to page 13. Yes, we are. 13, 22, 23. Okay, 13, 22, 23. 13 coming. Okay, so on page 13, that's what we see we have. Ooh, all right. Kendra collected data for the science project. She surveyed people asking how many hours they sleep during a typical night. The chart below shows each person's responses compared to 8 hours. Okay, and plot and label each of the numbers in the rightmost column of the table above and on the number line below. Okay, so here we have. Okay, so the average amount of hours, they say that most people should sleep or do sleep, is 8 hours. So Frankie over here, and let me make a number line. I don't need a big one. I need to go up to 2 over here. That's 0. I need to go up to negative 2 over here. That should be enough. Okay, most people sleep about an average of 8. So Frankie sleeps 8.5, which is 0.5 more than the average. So here's 0.5 between 0 and 1. And then Mr. Fields, I'm sorry, he sleeps 7 hours, which is 1 hour less than the average, so that's negative 1, so that's here. Okay, I don't wonder what should I put. Well, I just put negative 1 on top of negative 1. And then we got Carla, 9.5 hours. My God, lucky her. 9.5 would be between 1 and 2, which is 1.5. Louis sleeps 8 hours exactly, which is right here, so he's not sleeping more or less than the average. And finally, Tiffany sleeps 7.75 of an hour, so she's down a quarter, or 15 minutes. So that's her negative 1/4 right here. Negative 1/4. Okay, so in order, the smallest number is the number to your left, negative 1, and then negative 1/4, then 0, then 0.5, and 1.5. And I did letter B. Using your answer from part B and equality symbols, write one statement that shows a relationship among all the numbers. Oh, you can do this. We haven't done this in class, but you can write it like this. 1/2 is less than negative 1/4, right? Which is less than 0, which is less than 0.5, and which is less than 1.5. Okay? En la próxima página, la página 22. Yep, page 22. Wow, that's all you got today? Really easy questions. Andrea and Marta are testing 3 different coolers to see which keeps the coldest temperature. They place a bag of ice in each cooler, close the cooler, then measure the air temperature inside each after 90 minutes. The temperatures are recorded in the table below. So cooler A, B, and C. Cooler A was negative 2.91 degrees, cooler B was 5.7, cooler C was negative 4.3. Marta wrote the following inequality statement. She wrote that negative 4, and I'll write it here, negative 4.3 is less than negative 2.1, which is less than 5.7. Her other friend says, no, that's incorrect. You can't write it like that. You should write it that -2.91 is less than negative 4.3, which is then less to 5.7. Is either student correct? Well, what I would do is create a number line. Okay, all right. And I would place those numbers on the number line, and then we can look at the inequalities to see if either of them are even correct. So here we go. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. I'm going to go -1, -2, -3, -4, -5. We don't need anything bigger than that. So let's place the numbers. So the first number, let's just use this one, -2.91. I'm going to change colors. -2.91 is about here, very close to -3. Okay, that's right here. And then with another color, I'm going to do -4.3. Well, -4.3, well, we're walking. -1, -2, -3, -4. So -4.3 is a little bit, it's right here. And then with another color, I'm going to plot 5.7. 5.7 is positive, so it's on the right side. 1, 2, 3, 4, 5. And 5.7 is very close to 6. And that goes right up here. So there is our order of numbers. Our smallest number is -4.3. Our second smallest number is -2.1. And our biggest number is 5.7. Are any of these two girls correct? Well, first girl said -4.3 is smaller than -2.1. True. And -2.1 smaller than 5.7. That is a true statement. This other girl said that -2.1 is smaller than -4.3. But you know, it can't be right because look at our number line. -4.3 is the number all the way to the left. Remember, number on the left will always be the smaller than the number on the right. Okay, so this girl did it incorrectly. B, the students want to find a cooler that keeps temperature inside the cooler more than 3 degrees below the freezing point of water after 90 minutes. Indicate which of the tested cooler means is going to explain why. Freezing cold water, Celsius. Okay, so they want to buy a cooler where after 9 degrees the temperature is more than 3 degrees below freezing. Well, Okay, still gonna draw another number line. That's 0. And cooler A was negative 2.91 degrees. Cooler B, which you definitely don't want to buy, was 5.7 degrees. And cooler C was negative 4.3. They wanted to be 3 degrees less than 0. Okay, and let's make that barrier right here. This is negative 3. So this cooler is definitely not 3 degrees less than 0. This cooler is definitely not. It's close to, but definitely not 3 degrees less than 0. And the only cooler that is 3 degrees less than 0 is cooler C, which is at negative 4.3. So the one I want to buy is that cooler. Okay? And we have one more. What does that say? Mary manages a company that has been hired to flatten a plot of land. She took several elevation samples from the land and recorded those elevations below. So these elevations, elevation obviously means up. So A, B, C, D, E, F, you can tell them that they are different elevations above sea level. So A is 126 feet and a half above sea level. The landowner wants the land flat at the same level as the road that passes in front of it. The road's elevation is 830 feet above sea level. Describing words how elevation samples B, C, and E compare to the elevation of the road. Okay, so I wish I could draw this, but let's see if I can draw this. Here's the water, sea level, so that's 0. So the road is about here, which is 830 feet up. Okay, that's my road right here. All right, and then there's land. So let's look at B. B okay, so here's a road, and then there's B. It's a little bit above 830. That is at 830.2 feet. So if you're creating a road and you have to pass through this little land here, you would have to flatten how much to make it 830. So the landowner wants to make the height, maximum height he wants to make is 830. So there's a little patch here, there's a little bump that he would have to flatten, and to flatten he would have to flatten 830.2 minus 830, 0.2 feet. Okay. Of land, so that the land is straight. So that's what he has to do for B. For C, so he flattens that part, and he gets another part of the land, and this part of the land a little bit higher. Here it's 832 feet. So again, to flatten this area, he would have to flatten how much land? What's the height here? Above the 830 that he wants, it'd be 832 minus 830, which is 2 feet. And then E. Well, in E, as he's, again, doing the row, E, the land sinks a little bit. And sinks to 825.8. In this case, okay, as he's making the road, I guess he would have to fill this, okay, with sand or cement or something. And how much does he have to put in there? Well, if he wants to make the height 830, okay, there's a little hole in the ground here, you have to do 830 minus 825.8, which is 4.2. See, this little height right here is 4.2 feet. Okay. The table below shows how other elevation samples compare to the level of the road. Okay, so write the values in the table in order from least to greatest. Okay, that's fun. So What I would do is I would create a very crooked number line. Kidding. And I would plot those points. Okay, so let's see. My number 1, 2, 3, 4. So 0, 1, 2, 3, 4. -1, -2, -3, and -4. And apparently I need a -5 here. -5. So 3.1, 3.1, and I guess I'll trim with colors. It'll be right here. 3.1. 0.5, this is 0 but negative, so 0.5 negatives is right here. Negative 0.5. And then 2.2 would be about here, a little bit bigger than 2. Then you have 1.3, and then 1.3 again is just a little bit above 1. And then you have negative 4.5, so 0, you're taking negative 4.5 spaces back, all the way back. And negative 0.9. Negative 0.9, which is a little bit less right here. Negative 0.9. Wow, I can't even see that yellow. Pretty, huh? Alright, so now you have them in order. And you can write your statement. Okay? Uh-oh, too much. Wait, come back. Okay, here we go. So, remember, the number to the left is always the smallest one. So you can write an equality, a long inequality actually. You can say negative 4.5 is less than negative 0.9, which is less than 0.5, which is smaller than 1.3, which is smaller than 2.2, which is smaller than 3.1. Okay, it's a big inequality. Indicate which of the values from the table in part B is farthest from the elevation of the road. It's farthest from the elevation, and that would be, I'm going to say, K. Okay, negative 4.5. So again, imagine if this is the water, and right here where you're making that road, that's 830 feet. Okay, so that's 830, 830. You have one value here where it's 3.1 feet, that means above. So there's one part of that road where it elevates to 831. So you're 833, I'm sorry, 833.1 because it's 3.1. Let me repeat that. Okay, that's 830, right? So there's an elevation G, which is 3.1 feet above that. So 3.1 feet above that would make this 833, right? 830 plus 3.1, 3.1. So that's how much higher that is. But there's another stretch of the road where it sinks down quite a little bit. And that sinks down how many feet under? Negative 4.5, which makes this 825.5. So the biggest difference there is from either an increase, a height that's above 830 or below 830 is this one right here, which is this number right here. That number is furthest away from 830 than any other number. Okay. La, da, da. And that's it? No. Really? No, it can't be. Wow. That's pretty bad. That's it? Nothing else? Huh. In that case, let's go back. There's not going to be a secret message, but instead, I'll do something else, which is going to be Okay, there's the answer to this is your secret message. And that's that.